Hi, let's talk about the best development tooling in the world. My name is Oleg Selajev, and I work as a developer advocate at the company called Atomic Jar. Atomic Jar is a startup made by the maintainers of the test containers libraries, and you can find me online and ask me any questions because this format is, of course, hard to make interactive. Let's get into it. Java ecosystem is vast, is great, is really, really strong. And what we know is that it is very often the default choice for enterprise applications. And there are millions of applications and projects written in Java, and it's universally great. It conquered the world. And why it did that? There are different opinions. But what James Gosling, the creator of Java, says about that is that probably the key thing that made Java so interesting was the nature of dynamic loading of the libraries and packaging the libraries in the intermediate format for easy consumption. This allows the ecosystem to create libraries for all use cases and purposes, libraries, agents, monitoring tools. All that is thanks to the dynamic nature of Java. And within the Java process, there are libraries to do anything. Java is a self-contained world, and it has an excellent tooling from start to finish, from your IDE to the libraries that it allows you to do, to the frameworks that allow you to create applications easy and in a very straightforward and efficient manner. Java is great. But nowadays, we are not just dealing with applications that run within the process. Nowadays, we need an environment where the application needs to run. That is especially true in the world of microservices, where your application talks to different technologies and different other APIs that needs to run. It needs to run efficiently. And then, of course, Java cannot manage that because those applications are often not written in Java. They are separate. So in order to give you this unified experience, you need something else. And that something else, for a number of years now, has been Docker. Docker excels at packaging and making software runnable on your machine without any concern how that software was packaged and created. It isolates the software creation and packaging from your ability to run it. So now those two together are perfect to create efficient applications that can run and require any kind of technologies for the well-being. So whatever your role is and whatever methodology you practice, right? The software development cycle follows the natural path of the inner loop, creating the applications, coding, building them, testing them, and then releasing them into the outer loop of operations world, deploying, monitoring the metrics, operating, scaling the applications, and feeding that information back into our inner loop. So in this world, my experience is mostly as a developer. So I will concentrate on the inner loop development, on the developer productivity of coding, building, and testing. But both technologies, specifically Java, is very, very much excelling at the outer loop characteristics. It's easy to operate, it's easy to monitor, and well, it runs everywhere. So let's get started. How does Java and Docker create the best environment for you as a developer for coding? Well, first and foremost, Java has the best, probably the best and most sophisticated in class IDEs. The IDE is your friend. You should learn to master it. You should learn to appreciate it, and you should learn to rely on it. There are some use cases, and there are some voices in the community that saying that not always you have the ability to run your IDE. For example, you need to review code when you are on the go, so all you have your phone and you need to check the diffs, but those are niche use cases. as a developer, you almost universally have access to your IDE of choice. My IDE of choice is IntelliJ IDEA. It provides me with the best experience, but also I have been using that for a number of years. So I feel that I'm proficient with this. I feel I'm effective when I use this. And in this presentation, I'm going to be using Test Containers Cloud, a service by Atomic Jar that allows you to run containers during the test containers-based tests. So I'm going to use this to not download Docker images on my laptop. I'm currently on vacation, so I don't want to stress the network at this hotel. And also, it's going to just take an awfully long time to download all the images. So I'm going to run the containers in the cloud. I'm going to use my IDEA, IntelliJ IDEA, and let's see. Let's go into it and let's see what it feels to create applications nowadays with the modern technologies. Here's this example application. This is a Quarkus application. It does very little. It takes the requests that I send to HTTP and it generates me prime numbers. So it generates me a prime numbers between the 2 and whatever the parameter I'm passing. The logic is not necessarily relevant here, but what it also does, it logs the metrics into the Kafka topic. It wants to send the information about how long it took to calculate certain prime numbers to Kafka. Can I run this application? Yes. Do I have Kafka running on my machine? Absolutely no. Do I have Docker running on my machine? If I do Docker PS, I have no applications running in my Docker. However, this is a Quarkus application, and Quarkus takes pride in working with what they call a developer joy. So when I run my Quarkus application, Quarkus dev, what happens is that Quarkus realizes that I need a Docker environment, that I need a Kafka service for my application to work with. And it knows that there is no Kafka configured. So what it does, it goes and provisions a Kafka instance for me. This is what the developer experience should be about. You don't necessarily know that the application requires some technologies. And if you don't configure them in development, the application can take care of your needs. So what Quarkus created, Quarkus pulled the Kafka image into my Docker environment and started the dev services for Kafka. Now my application can work normally. If I, for example, generate some prime numbers from my application, which is running at localhost 8080, you can see that I'm only getting back prime numbers. The application works and it sends messages to Kafka. Interestingly enough, if I would create another service that requires Kafka, it will connect to the same Kafka. Very often, when you work on the microservices that communicate through the message queue, where you're using Kafka as the message queue, as the communication bus between different services, it doesn't make sense if every service creates their own Kafka instances. And you want them to communicate. You want them to send messages and read messages from the same instance. And the dev services do exactly that. If you run a number of services, they will connect to the same Kafka instance, making your experience working with this application, on this application, an absolute joy. You can change it as you want. You can run it as you want. If you need a database, if you add the requirements for the database, the Quarkus Dev Services will create a database for you, will provision it for you. You don't need to think about how do I run Postgres? Can I run it locally? Can I not run it locally? The same is true for the tests, of course. So that is Quarkus. Quarkus have dev services. Micronaut has Micronaut test resources, which operates in a very similar manner where you start your application, and if it uses an external resource that is not entirely Java dependent, the test resources will create and provision an instance of that for you. The question now is, can you do the same in Spring? And the answer is, of course, yes. Spring is an incredible project. And just recently, they've been working on integrating this experience, this automatic creation of environments into the normal application lifecycle. They took a little bit different route. So what you have your normal application in your main class path. You can run it. It will require, this is a to-do application. So I would need a relational database to run this, Postgres in my case. And I will not run my application from my main class path. I want my application run to have access to the test containers libraries, to this Docker integration that it provides. So what I will do, I will create a test application in my test class path, and I will instruct it to run my application, but with the custom test configuration, which will tell me that my application needs a Postgres container of the particular version. There is no configuration that you need to do. You need to declare what images do you need to run. This might be a good thing because you not necessarily want to rely on the defaults that the application framework provides. And here you explicitly need to choose the particular image, but you can do that. You declare this method, returning a beam that will be the container, which encapsulates the information how to access the particular instance of Postgres running in Docker, and you mark it with the service connection annotation. The service connection annotation comes out in Spring Boot 3.1, which should be coming this May, depending on when this presentation airs. It's either in the future yet or in the past. I'm using the RC version of Spring Boot to show you this functionality. But all in all, this service connection interface will do two things. First, it will take the result of this method and it will start it. So we will not just have the container with Postgres, but it will be actually running. It will wait for it, for the container to actually run and the database be ready in there. But it will also, the service connection will configure our Spring application to use that particular database instead of anything else. So when I run my test application here, what actually happens is this very same thing that we saw with the Quarkus Dev Services. Welcome to the future. You don't need to take care of various pesky details of where your databases are running. My container is starting, my Postgres 15 Alpine have been downloaded, and then Flyway runs my migrations, everything starts, and I can now access my applications. So if I post a to-do into my application, you can see that my to-do is coming back. And I think I can just even access it from the browser. You can see hello world have been just completed. We can do Java stage world and run it again, just to show you that there are actually no tricks here. And we can see another to-do. Where is this information stored? In my database. Where is my database running? In my Docker environment, which is currently my test containers cloud. So it doesn't run locally on my machine, but it runs in a data center somewhere nearby. But in that Postgres, I can store my information. This enables me the spectacular integration between two different worlds, which I need as a developer to run my applications efficiently. I need my IDE to work with the technologies, and in my IntelliJ IDE works beautifully for this. It has integration with the test containers libraries as well. So for example, I can open the details, small things that makes IDEA work with for me very, very well. Integration with opening the links to the Docker containers, the content assist on strings within Docker names. So I can finish that. Also, I think there is some even custom actions that my IDE provides for my images for my integration with test containers. So this is an incredible feat, right? I can create the environment for my application to run in a few lines of code. In this case, this is Postgres, but you, of course, are not limited to Postgres, and you can use anything that runs in a Docker container for this with maximum flexibility. I'm going to stop this application, not to clock the port 8080 for the further demos, but here's what we do now, right? What we created. We used test containers, we used the local development environment in Quarkus and in Spring Boot 3.1, which is very new and exciting, to create and run our applications as if they were standalone and isolated. And as a developer, you don't need to think about any particular details. That is what the tooling is for. Your IDE, your Docker integration, your libraries, your application framework. It all comes together to allow you as a developer to concentrate on creating business logic. So of course, you can create some containers, and this integration relies on test containers. So test containers is the libraries that allow you to integrate and run anything in the Docker environment, giving you the programmatic API to manage those services in it. And it comes with an ecosystem of modules. The modules are vast. They cover almost all normal popular relational databases, message brokers, other technologies like HashiCorp Vault or local stack for the AWS applications. Anything that you can run in Docker, you can run in it. And a very recent addition that I want to show you is the modules on the testcontainers.com website. You can see there are more, I think there are more than 50 modules currently. Some of them are called official modules, which is where the vendor behind the particular technologies chose to maintain the test containers integration, saying that test containers is the way to test applications running against their software. So hopefully there will be more and more of those officially maintained by the vendor modules, but this is a very, very good start. So this is how applications, your Java and your Docker work together to provide you with the best user experience while you code. Now let's talk about tests. Tests are essential. Tests are on the critical path from development to production. Tests are something that every developer should be doing, but they're very, very hard. Very often, they are hard to get right, and very often developers feel that tests are more of a chore. So there are different ways to organize the tests. However, unfortunately, very often tests sort of devolve into this testing Dorito. So you start with tests you plan to write, and then there are fewer tests that you actually start writing, and then you delete some of the tests because it's they are not proving some value to you, and then you have just a little bit of the tests. This is, of course, a sketch on the testing pyramid, which consists of the unit tests at the bottom, integration tests in the middle, and hard to maintain and fragile end-to-end tests at the very top. That is a paradigm that we feel has been very popular in the past. And nowadays, more and more teams and more projects transforms their understanding how to organize the tests into this more honeycomb shape or different shapes where the integration tests take the largest chunk of the your test suite. The reason for that is that you want tests that give you the best confidence in the fact that your software actually works. There are some tests and some use cases where you need to cover a lot of implementation details with small, isolated, working in isolation, testing a tiny, tiny piece of Java code test. But very often, especially in microservices, what you want to have is you want to make sure that your applications will work with the technologies they're supposed to work, that the configuration is proper, that the application can ingest the configuration from where it needs to take it, and it works with databases, it works with the incomplete state in databases, it works with the broken state in your data store. It can find documents in Elasticsearch, and so on. So the integration tests become the bulk of your test suite because they give you the highest confidence while still being very, very easy to maintain. This is where, of course, the test containers comes in. Test containers is the programmatic way to manage the environments for your test application, for your application tests. It gives you the flexible API where you as a developer can weigh whether you value isolation of the individual test cases or convenience and performance of your test suite more, give you the abstractions like we saw at the modules to build higher and higher higher and higher abstractions to run for your particular use cases. It gives you the ability to create complex topologies, and it also takes very much care about making your tests follow the best practices. Test containers tries to randomize the resources that are exposed and used on the host, so there are no conflicts if you run things in parallel. It gives you the default use of weighting strategies. So when you run certain technologies, it's not just the container that has been started, but it's the whole application within the container is started as well and ready to serve, whether that is a heavier, slower to start database, or a message broker, or a technology like local stack that pretends to be your AWS cloud. Weighting strategies allow you to rely on that and write your tests as if everything is instant and synchronous. So it waits for those asynchronous events by default normally. Everything is done with the idea that parallelization is the best way to speed up your test execution. So everything is parallelizable, which is, if you think, tests are the embarrassingly parallel problem. Every test can be run in isolation. So if you throw like all the compute in the world at your test suite, everything can be run in parallel. So doing things that prevent parallelization is super counterproductive. So test containers doesn't do that. And all in all, it gives you this unique experience where every test feels like a unit test with the information embedded in the test, but it runs like the integration test. Let me show you. Let me show you. Here's my application. It's a Spring application. It deals with something, but the important part is that it uses the relational database to store some of the data. It uses Redis to store some of the other data. And it also uses Kafka to send messages to Kafka and receive messages to Kafka for some other data. So now to run this application, I need this whole environment. And I think I can could I maybe run this? Could I maybe run this information? Do I know how to run Kafka in the Docker container? I do. For example, so to run Kafka, what I need to do, I need to create services, I need to specify the zookeeper and expose some ports, and I need to run the Kafka and configure something. And this configuration is static. This is just Kafka. So that application will not still run because it needs Redis and Postgres as well. But I can figure out and I can Google how to run particular technologies in my Docker containers myself. But why would I? My application can run very, very naturally by using the test containers dependencies. Well, this is where test comes in the test containers in general, right? It wants to be the application dependency that provides you with containers for the tests. So what I can do, I can import the test containers dependencies. Where's the base one? Here's the base one. The integration integrate with my JUnit lifecycle if I want, and import the modules that we talked about. So all the individual modules and the integration with particular technologies are in separate artifacts, so you can pick and choose which exactly you want. So this application imports way more than it needs to show how convenient it is, but I can get Kafka, I can get my Red Panda, which is a Kafka implementation that is faster to start and allegedly more efficient. I can import my Postgres, my Kubernetes cluster creation, Mongo, MariaDB, Cassandra. All the technologies there are at your fingertips. Now, after that, what I can do, I need to create the environment. I'm going to create it in the abstract class that my test classes will extend. But this is what I want to make you look at. So we saw how to create a little Postgres container. This is how you can do this as well. The Postgres container obviously comes with the library that we just specified in our POM XML. So I will specify which image I want to run, and I will specify the configuration. It's not just about running and starting the containers. It's about running and starting the containers for the particular use case that you want to test for. That means it needs to be initialized with a particular data. It needs to be initialized with a particular configuration for your, I don't know, Kubernetes cluster, or for your Kafka container if it needs to have a custom configuration. So test containers gives you the flexible API to do that. For example, we can mount our schema application into the Docker directory in the container. Why this directory, you ask? Because if we go into the Postgres and we look at initialization of the database, these scripts under that particular directory will be executed at startup. So that's how I create my schema. That's how I initialize my database. So I can copy files there, and I can do anything I want with this container. I can copy files, I can expose particular ports if I need to access my application from the outside. I can configure the environment variables, I can override the commands, I can override the command modifier if I want to limit the resource usage, and I can do all of that within the comfort of my IDE. I don't even need to know that I can do any of that particular stuff. I can just type dot and just find what I need, which is the perfect experience for development, because very often when you don't 100% know what you need and the solution is not at your fingertips, you will build workarounds. You have a vague idea how to do things, and you will follow it, and you will do it, and you will build it. And it will not be ideal, and then you will have to maintain it forever. So we create the Postgres, we create the Kafka container by just saying like new Kafka container, because we imported the test containers library, so we don't need anything else. And we create Redis by just using the generic container lower level API that allows us to do anything that the Docker container does, but not more specific container technologies like specifying the database name or something. And we say that we want to run Redis, we want to expose the particular port, and then our container definitions are done. What are we going to do now? We need two more things. We need to manage the life cycle of those service dependencies, and we need to configure our application to use that. So the life cycle is fairly simple. On every container, of course, we can use the start-stop methods if we want, but we also can use the utility methods from the test containers library that will start all of them in parallel. This is pretty straightforward. We're going to start Redis, Kafka, Postgres, and after they're started, we're going to use those containers to provide the information how to connect to them into our Spring application. For that, we're going to use the dynamic property source, which is the mechanism if you want to customize the service connection that we saw earlier, or if you are using the older Spring Boot release, which doesn't come with the service connection yet. Dynamic property source is how you provide the dynamic properties into the Spring application, which we are using to get access to those technologies, right? This is all. Those 20 lines of code is everything that you need to create a complex environment with 3 technologies running in containers. And we're going to start them, we're going to run them, and we're going to stop them. We're not stopping the containers. Note about this. Look, Docker PS. There is nothing running here. No containers running for me now. And then if I go to demo application test, I can run my little test suite. So I'm going to run my test suite, and we're going to see that my containers are being started. My particular version of Kafka is being pulled. This will just take a second, and test containers will naturally piggyback and use the Docker cache mechanism. So if the image is already downloaded and used, then it will not need to pull them again. You can configure whether you want to pull always or use the Docker cache. Everything is configurable. There is an API for that. But in a very short period, our tests are starting to run. Now, our containers are still there. So we started the containers, we ran our tests, the containers were there, and then they were gone. How did that happen is that test containers take extra pride in cleaning up the environment. Nobody wants the containers to linger after the tests are passed. No one wants the tests to connect to the Kafka instance that was running for a couple of weeks because somebody forgot to clean up. So test containers, whether your tests pass, fail, or crash, test containers absolutely takes the cleanup into account and removes the containers without you even actively working on it. So we can run our tests. It runs in a complex environment like this, and it just takes 20 lines of code to create this, because you have the abstractions of test containers, because your IDE helps you work with all the options that are available for you. For Kafka, for example, embedding Zookeeper, not using Zookeeper, anything like that. And in the configuration, so here as well, right? You can start typing things, and if you know that you need the bootstrap services property to configure a Kafka, you can have the particular helper method on your test containers library that will give the developers the convenience API to do that without knowing the particular details of what needs to go into what property, environment variable, and everything that to run your software and to configure a software. So this is how test containers helps you for the tests. Note how the tests that I'm running here are the normal tests. They're not complex. They are not like any time I'm running Maven tests, I'm going to run this. So you can do all kinds of cool things, right? So this was running against the sort of the conventional technologies. Here's an example. I can run against a Kubernetes cluster. Here's my demo with Kubernetes. What I'm doing, I'm starting the K3s container, which is the Kubernetes implementation by Rancher Labs. I start that, I create my application, I create my deployment, it is Nginx, and I can run it. Look, in my Docker container, I can create a Kubernetes cluster, and I can deploy something into that Kubernetes cluster from my test myself, which is particularly funny, right? So here we deployed an Nginx into our Kubernetes container and didn't do anything with it, but you get the point. If you're developing against the Kubernetes, for example, Kubernetes operators, this is God's send. And the same with other things. If you, for example, develop against the AWS technologies, what you can have is you have the local stack technology, which is the local individual solution for the AWS stack. So it provides you with the clone of the AWS services that you can use. You can run them locally in a Docker container. And obviously, if you can run it in a Docker container, you can run it through test containers. So very naturally, I run this with my in my test. So I can register it the same way by providing the endpoints to my Dockerized local stack installation into my Spring, and I can have my AWS in my Docker and use it. And if my application needs to access S3 or Dynamo or create Lambdas, I can do that very, very naturally from my tests. This is the test containers experience. This is defining the API and using the API to control what environment my application needs to run in, and then having my tests that work with real technologies, but you look and feel like unit tests. I can run them individually. I can debug them from my IDE. I can change small things and rerun them without repackaging anything. It is a bliss to work with. And now, of course, after that, we also can do things for the releasing things. If you have the API, and there is let me just show you a very, very quick demo. If you have the API, again, for example, here, Docker files. I can package my application to run using the Docker file, and I can package my application. I need to run in a native world, but it all is the separate configuration. One technology that I want to talk about here for packaging applications is the build packs. Build packs are it's going to be funny if it won't work. Build packs know how to run my particular technology and how to package my particular application. Something is wrong with this test. I'm going to debug it later. Here's an example. What I mean, if I have my build pack and my application is Spring application, the build packs know how to package my Spring application. You don't need to provide the particular Docker file, but you also, in our case, you don't have to do anything in particular. You can use that from your IDE to run the test normally, as you would do. And you control the build packs and packaging your applications using the build pack service. So what we can do here in this particular test is that we can package our application into the Docker container, and then we're going to use the generic container for that particular final image that we just created one line earlier, exposing the AT80 and starting the app. And then we can check that our application actually responds what it needs to by running it in the exactly way it's going to run in production, being containerized and not running locally. You can also, the same way, very conveniently use test, for example, the native image applications, where if you convert your application to the ahead of time compiled native binary, you can build it again with the build pack. You can use the generic container API to run the test image. And you can notice that the test here and test here are exactly the same test with just a different Docker image name. So if you are building native Java applications, testing them with test containers, testing them in the same way on the higher level integration test is probably the way to go. So You use a different build pack that specifies that you want to build native. You use the same test that specifies that you want to run this container, and you can test your native applications and your Java applications running in a jar file like normal in the same way. This will help you release software. This will help you run the applications properly, and this will give you a lot of developer joy. So this was it. I just wanted to give you a couple of resources now. If you are interested in test containers, go to testcontainers.com. You can use any sort of IDE. It doesn't have to be IntelliJ IDEA, but use the one that you're proficient in. And if you have any questions, please come to join the Slack at slack.testcontainers.org to hang out, to ask questions to me or to the community. And if you're willing to check out testcontainers.cloud to run the containers during tests in the cloud without running locally, it is testcontainers.cloud. All in all, we went through the inner loop and showed how Java and Docker together give you the best experience that you can want as a developer and make you incredibly productive by taking care of all the details that you don't want to mess with: the environment creation, starting the external services, the cleanup of those, writing tests, integrating those external services into your tests, using that for the local development environment. All of that is taken care of, and you can be as productive as you want to. Thank you very much.